right, this is number 4. Yada, yada, yada. This is a whole bunch of information that's not necessary. It says compute the correlation between length and weight for the height for these fish. So the length is going to be my x values, and weight will be my y values. I'm going to put these into L1, and these values into L2. So you're going to get your stat, edit. I already did all that. So there's 2 ways you can find the correlation coefficient of these 2 data sets. So the first way is you can run a lin-reg t-test. So I'm going to stat, over to tests, and I'm going to scroll up until I get to lin-reg t-test, option F. And I'm going to hit X list is from L1, Y list is from L2, frequency is 1, and just make sure this beta and rho thing is going to be equal to not 0, not equal to 0. And they're going to hit calculate. Gives you a bunch of stuff. You'll use this for a lot of the questions. But all we care about is R. That's the correlation coefficient. Okay, so once our answer to the nearest 0.001, so that's going to be 0.968. Another way to do it, if you remember from 100, if we had 2 sets of data like this, we could find the linear regression line. But before we do that, we want to make sure we have extra information given when we find the linear regression. So what I'm going to do is I'm going to hit second, the 0 button to go to the catalog. Okay. Once there, I'm going to scroll down to the D section. I'm looking for the word diagnostic on. It's going to turn on diagnostics for that kind of test. So here's diagnostic on. Hit enter, and then enter one more time. So that's done. It's all set. So now, since the data is in the stat list, I can hit stat, calculate, and then just like we did in MAT130, we're going to hit lin-reg. X1, X is L1, Y is L2. Calculate, and we get the same thing. A and B, R squared, then R, that's all we want is 0.968. So really it's up to you which one you want to use, okay? But the answer here is 0.968. Number 7, it's the same thing. This is just the readout. Look, that's the same readout we got in this problem. It's got Y equals AX plus B, then we have A, B, R squared, and R. So the regression was run to determine if there's a relationship between hours of TV watched, which is X, and number of sit-ups a person can do, which is Y. And here's the results. So I don't need these 2. This is just like a MAT130 problem. So my equation is going to be Y equals A, which is negative 0.668, X, plus B, 24.202. It says use this to predict the number of sit-ups a person who watches 8.5 hours of TV can do. So X is going to be 8.5. So I'll just do negative 0.668 times 8.5 plus 24.202. I get 18.524. 1 decimal place would be 18.5. And that is your answer.